Okay, so I thought I'd go over section 7.3, and this is just the basics of logarithms, the properties of logarithms, essentially. And what I have here are three basic properties of logarithms. And the first one says that if you have inside the parentheses two things being multiplied, you can actually split that up as log base a of x plus log base a of y, and the a can be the number, right? Any base like 8 or 5 or 10, whatever it would be. If you have some type of division within these parentheses, then you can split them up with subtraction. So this is equivalent to this. And then lastly, if you have something raised to a power, well, you can take that power out and bring it to the front and say y times log base a of x. All right, so there's the three basic properties. We talked about that in class, but I'm going to use that for this whole section here. All right, so number one says that we want to try to expand this as much as possible using the properties of logarithms. Simplify any numerical expression that can be evaluated without a calculator. So what I want to do is spread this apart using those properties. So I see some multiplication here, and I also see a power. So there's those two properties I'm going to use, this property and this property. We always use this one first, and then this one second, if need be. So I'm going to split them apart first with the addition rule. So log base 6 of 216 plus log base 6 of x to the 7th. Well, now we need to take that 7, chuck it up front. Log base 6 of 216 plus 7 log base 6 of x. And this right here would be 3, right? You ask yourself the way logarithms work, right? It's this guy to some power equals this. And checking your calculator right now, 6 cubed is 216. So this guy is 3. But you can't do anything with this because there's a variable there. So we just say plus 7 log base 6 of x. That's as far as we can expand that, and we can simplify a few things. So, try number 2. Oh, remember, this is log of any base, and that base is can be e. Remember log base e? Log base e is the natural log. Log base e is the natural log, ln. So the same properties work for ln's. So I see a division, and I see a multiplication, and I see some powers that are going to get put to the front. So I'm going to use all three of my properties. So this is number 2 on our worksheet. So I'm going to do the division part first. I'm going to split it apart first. Seems like it works out a little nicer if I do that. Okay, so I'll split that apart. Remember, I'm going to split the addition part away. Split this apart with addition. Okay, now, natural log of 11 is just natural log of 11. It's not a whole number. It's not anything like that. Just leave it as it is. 2, bring it up front. The 3, bring it up front. So you're left with the natural log of 11. 2, so I'm going to bring that 2 up. That's what I'm going to do. Natural log of x. And that 3 is going to be brought to the front here. Minus 3 natural log of y. That's as fully expanded as you can get. Okay. All right. Number 3, same directions. We're just going to expand this thing out as far as possible. There's number 3. And there's no property that says anything about two things being added inside here, right? There's not a property for that. Only thing that you can do is hopefully factor something out of this. And you can factor a 4 out of both of these. So here's the trick. Factor a 4 out of both of these. All right, 2 times 4 is 8. 4 times 3 is 12. So this is equivalent to that. Now, we're multiplying now, right? 4 times this. I can split that apart right here. I can split that apart with an addition. So log base 4 of 4 plus log base 4, 2x plus 3y. Now, what power do you raise 4? What power can you put on 4 to get 4? 1. Right? 4 to the first power is 4. So this right here becomes a 1. can't do anything with this because there's a bunch of variables in it. So, and you can't factor anything else out of that. So this is as far as you can go. There's number 3. Okay, the directions start to change now. Now they give you the expanded form, and they say use the properties of logarithms to condense the following equation as much as possible, writing this answer as a single term, coefficient of 1. All exponents should be positive. So we're just going to basically do number 2. This is number 2. We're going to do number 2 in reverse. Okay, we're going to take our powers, we'll put them up here. We'll put together this addition part, where I'm just going to work left to right. I'll put together the additions with the multiplication. Then I'll put together this minus here with a division. So I'm just going to work this backwards. So natural log of 14 plus natural log of x squared minus natural log of y squared. Now, I'm going to put together this, I'm just going to move left to right and just put this together. So there's a plus here, that means multiply. So there I'm multiplying those two guys together. Now I'm going to put them together with division, because there's just a minus in between. Notice I only have one ln, that's the key. There's only one ln. There's a parentheses around it. I've used parentheses everywhere through here. Do not get lazy and not write parentheses. So there you go. There's your, it's condensed as much as possible. And there's our answer, number 4. It's basically like number 2, just in reverse. Now there is another property that says if you have a number raised to the log base of the same number, see how these are both the same? Essentially they cancel and you're left with x. Okay, that's the way I look at it. So, for instance, 3 to the log base 3 power of x, guess what that is? Cancels, you're left with x. Right? That's the idea behind it. So, I see this guy. Looky here, I got a 9 and a 9. And what we're trying to do is just use the properties about this direction, say use the properties of logarithms to write the following expression as a single term that does not contain a logarithm. Well, I can cancel these two guys out, but that 2 is in the way. I wish that 2 wasn't there. It's kind of like this little bodyguard for this. But, you know, there's a property that says if there's something in the front, you can move it up here as a power. So we could actually rewrite this as 9 log base 9 of x squared. Well, 9 log base 9 of x squared, essentially, I like to think of it as that cancels that. It's probably not the right way to mathematically think about it, like as a math nerd or, you know, the proper math grammar saying things cancel, but that's just the way I look at it. And you're just left with x squared. So your answer is x squared. Pretty neat little property. Number 6, the directions change. Once again, it just says evaluate the following logarithmic expression. Just evaluate it. Now, in previous chapters, this number, you could rewrite this as 17 squared or 17 cubed or something like that. These numbers aren't related at all, basically. You can't raise 17 to an even or a whole number power and get this. So you're stuck with basically using a calculator. And some of you have got fancy calculators that you can plug that in. Change of base formula. If you use a change of base formula, it says that log a big B. That's the same thing as saying just a plain old log, like log base 10. Log any base, really. But most people just use log base 10 because their calculators has a log button on it. It's log big B divided by log, that little a right there. That's the change of base formula. We're going to use that. We're going to say log of 185 divided by log 17 right there on the calculator. Here, do that on the calculator. It says to round the nearest to 2 decimal places. So what you should wind up with is 1.84. 1.84. I'll get one of these old school calculators down here. Let's see if this works. Oh yeah. So you just take log, was right over here. So log of, what is it, 185 divided by log 17, and you get 1.84. It's rounded 2 spots. So that's how I'm typing that in. Okay, let's try it again. Number 7, same directions. Evaluate the following expression rounded 2 decimal places. Well, this is a plain old ln, natural log, which your calculator can do. Plain old log, your calculator can do. So you just type it in. ln log 158, 2 parentheses to close it up, 0.78784. So 2 decimal places would be 0.79. 0.79. Easy enough. Same idea here. I'm going to clean this up a bit. You can take this right here and then multiply it by 3. I'm going to do it in one step. I'm going to take and chuck that over there. Right. 14 cubed is 2744, I believe. Let me check that out. Make sure 14 cubed, 2744. So log 3 of 2744. That's what I'm going to type in my calculator. So log 2744 divided by log 3. .21. 7.21. Using the change of base formula. Same way here. Just evaluate this dude is what the directions say to do. Log of 0.175 divided by log of 1/4. So log 0.175 divided by log 1/4. 1.26. 0.26. It says around 2 places. Around 2 decimal places. Last 2 questions that we got on our paper here. It's just I put these on there just to make sure you got the basics. Okay. When you see a plus and it says to condense, what's that mean to do? It means multiply. You multiply those 2 things together, and I'm gonna put the z on the end. That's okay with you because nobody puts the z in front of a number. So you leave the coefficient up front. So it's 11 times x times z. That's it. It's a very basic problem. Do you understand the basics? When you see a plus, it's multiplying. And what happens when you see a minus? What happens if there's a minus in between? You divide. And it's this guy divided by this guy. I have to put the z on top this time. In division, the order matters. That's 7.4.